I'm now going to look at the problem of image blurring and how we can stabilize the image if we can. So for certain pictures, a bit of blurring in the image can be quite useful to illustrate movement and that. But for most pictures, especially if the blurring is over the entire image, we want a sharp image rather than something that looks like this, which is caused by camera shake, and you can see that the camera has moved relative to the subject, causing an imprecise image. So blurring, the definition, we can use this definition, is the relative movement of the projected scene over the camera sensor, resulting in an unsharp image. Okay, so the image has actually shifted across the sensor during the exposure. So in order to minimize the effects of blurring caused by camera shake, we can employ various techniques. And we're actually talking about blurring caused by camera movement relative to the subject, not blurring caused by focusing errors, which can give us an unsharp image, or movement within the subject. So if we have a bird with flapping wings, a car with rotating wheels, those parts of the image will appear blurred, or could appear blurred, and the rest of the image appears sharp. So we're talking about an overall blurring of the whole image here, caused by unwanted camera movement relative to the subject. So we could use a solid mount to mount the camera on, the camera and lens on. So we can mount it on a solid wall or other massive object. We can use a quality tripod. We can use bean bags lumped on top of a wall or something. Can use clamps or other devices to attach it to fences, trees. We've also got some inherently slightly less stable but still effective techniques. We can use appropriate shutter speeds. Higher shutter speeds reduce the effect of camera shake. We can use a monopod or a shoulder stock. Again, these are supports that help restrict the movement of the camera during the exposure. Adopting an effective hand-holding technique, and I'll illustrate how to correctly hand-hold the camera shortly. Using the camera's built-in stabilization system. So a lot of the newer cameras have got some very effective stabilization systems built in, either into the camera or the lens. And we can use wider angle lenses. The wider the angle of the lens, the less relative movement we're going to get across the sensor if the camera moves relative to the subject. Note that blurring issues are amplified as our pixel count and final image quality output sizes increases. So if all we're doing is producing a little postage stamp image, postage size image, then the amount of blurring that you're going to see is probably going to be negligible. Whereas if you were to blow it up to a huge size print, any amount of camera movement will be visible in the print. So it depends on your output as well as to how critical this is. So tripods. Let's have a look at how a typical tripod is constructed. So we have a tripod head, and there's lots of different types of heads you can choose and different types of mounts that you can have. So it's worth having a good browse to see what you finally settle on. We've got adjustment locks, so we can adjust the legs or the flip out or whatever. Some tripods have got foam grips so that in cold weather your hand isn't on cold metal or whatever, so foam grips can be useful. We've got a center column. A lot of tripods have got a center column that can move up and down within the head here. A lot of them have got ballast hooks, so in windy weather you could actually mount a weight at the bottom of this to try and stabilize the tripod. Extendable legs. In this case we've got flip leg locks. Some have got rotating leg locks. There's lots of different types. Different types of feet. Some have got wide bases, little points on them. And we've got the construction materials. What is the tripod made out of? So a lot of the cheap ones, certainly in the early days, they were made out of steel, and these are usually quite heavy and cheaply made usually. Aluminium, it's lighter than steel and quality can be variable, but some can be quite good. Magnesium, this is usually restricted to the very best type of equipment. It's a very light metal. And carbon fiber. So bonded composite lighter, usually restricted to the top quality models. Right, so when we buy a tripod, we need to consider the design, the adaptability for camera positioning. Say some of the camera legs, we can flip them right up into different positions for positioning against rocks and stuff like that. The extendable height, so some tripods are fairly short, others are really tall, so you might need to consider the height that the tripod can get to or go down to. The weight of the tripod and the head combined, so you might have to lug this around for many miles, or you may need to take it on an aircraft when you go on holiday. The design load, so some tripods are they all have a limit to what they are designed to carry. Some are designed to carry little cameras, others are designed to carry really big ones with big lenses. So you need to decide what equipment you want to be attaching to the tripod, and make a selection based on that as well. Vibration dampening effectiveness. So if you put your camera on a potential tripod, look through the viewfinder of the camera, give the camera a tap, and see how long it takes for the vibrations to settle down. If it takes a long time, you know the tripod's not really up to standard. It should settle down really quickly. The head type and the quality of the type of head that we're going to choose, so that's important as well. Also the thread diameter, so the tripod will have a thread diameter which screws into the base of the tripod head here. So you may need to decide if that is important, a 1/4 or a 3/8 UNC thread size. And here's a little selection of some types of tripod heads. That's the typical ball and socket type. This is the Wimbley kind of support. So the tripod will also define what sort of head is applicable to it as well. So you need to decide the whole assembly, the tripod, the head, what you're going to be using it for. So traditionally tripods have been associated with a serious photographer, but you need to consider quite a few things when you're thinking of buying a tripod. So the type and quality. So no tripod is 100% stable. In the wind it'll start vibrating a little bit. Its design, construction materials, build quality, how it's used, and the environment of usage all affect the effectiveness of the stability of the tripod. And generally you get what you pay for. And never buy a cheap or flimsy tripod. You may as well save your money. So let's have a look at some of the techniques to aid tripod stability. So the choice of tripod head is important, as the tripod itself. Choose a solid, stable base to position the legs, on rocks rather than sinking sand or something like that. Don't extend the legs more than is needed, so keep everything nice and tight and compact. Extend the thicker portions first, so don't extend the little thin sections first, do the thicker portions. Try not to extend the center column like this. That is the least stable of all possibilities of usage. Ensure the camera attachment is rigid with no play. So a lot of these heads have got attachment bases, and these need to make sure that they are firmly attached to the base of the camera, and the attachment is firmly attached to the head as well, with no play. We can use a remote control, so rather than pressing the shutter button on the camera, we just use an electronic release, so we don't have manual intervention on the camera to induce camera shake. We could use mirror lockup if you want, but a lot of tests have shown that it's only effective with flimsy tripods and within a certain shutter speed range, so that isn't quite so important these days. If you use a long telephoto lens, attach the lens to the tripod. Don't attach the lens to the camera and then the camera to the tripod, because that will really mess up the stability and it could damage your camera as well. Shade the assembly from the wind. So if it's a bit windy, position your body so that you're upwind of the wind, so the tripod is shaded as much as possible. We can add weight to reduce wind buffeting, and that is where we can attach to the base of some of these tripods a ballast hook. Here we go, an illustration here. Turn off the camera's image stabilization system. So once it's attached to a tripod, we don't want the stabilization system interfering, because it can actually induce jitter within the stabilization system and cause more problems than it is trying to solve. So we've got other types of support. We've got bean bags. These are really effective. It's almost like a solid platform if you've got beans or peas or some other fairly dense material in the bean bag. Sand is another thing, but sand doesn't go very well with camera gear. I use actually birdseed, and therefore you've got a little bit of birdseed if you need to entice birds closer to you. We've got monopods, we've got gorilla pods, clamps of different shapes. We've got other supports, really weird things. But a lot of people tend to just take the pictures handheld. So adopting the correct hand holding position is really important. Okay. So use available supports. You can lean against walls, railings, cars, things like that. Support the camera in your left hand. So look at these illustrations here and try and mimic the way the camera is being held. Use your right hand to hold the grip and operate the controls. Keep your elbows resting into your body to provide support. Rest the rubber eye cup against your eye. More camera support. Hold the camera securely but not too tightly. Spread your feet into a stable stance. Gently exhale before the instance of shutter release. Gently rock the finger onto the shutter button. Don't jab or jerk. That kind of jabbing is probably one of the worst causes of camera shake. So it's just a gentle press. Follow through and allow the time for the shutter sequence to complete. So for some long shutter speeds, you need to keep your body nice and steady whilst the shutter is open, because it can take up to maybe a quarter of a second. Some of these handheld shots are possible, so you need to be follow through, and we need to practice, of course. So there's long been a shutter speed rule to try and give you some ideas to the sort of shutter speed that you need to minimize the amount of camera shake. And this is for an average person. So the shutter speed should be at least the equivalent fraction of a second as the focal length of the lens used. What's that mean? Okay, so if you're using a 50mm lens, you need at least a 50th of a second or quicker to get this kind of general sharpness for the average shot. A 200mm lens, you need at least a 200th of a second. Okay, that is the general rule, or it was the general rule. Trouble is, this rule assumes that you are correctly hand-holding the camera. Okay, so you need to have adopted those hand-holding techniques and practice to get this sort of effect. This rule assumes you're using a full-frame camera, film or digital, because it was produced in the days of film, 35mm film. So for crop sensor cameras, the shutter speed needs to be multiplied by the crop factor. So if you're using a 50mm lens with a 1.5 crop sensor, you now need to have a shutter speed of at least 1/75th of a second. Following? Okay. 200mm times 1.5 means you need a 300th of a second. However, modern cameras are capable of much finer detail than the cameras in the era when this rule was designed. So you may have to double these figures to obtain acceptable results, if you're going to produce a nice big print. Vibration reduction and image stabilization can help reduce camera shake effects, so shutter speeds can now be reduced. Okay, so we've been increasing the shutter speeds, but now because of this we can reduce it. So it's starting to get a little bit complicated now. So if we add it all up, we've got a 50mm lens with a 1.5 crop, which means a 75th of a second. We need to maybe double it for my rule, because it's we've got so many more pixels, it's so much crisper potentially. So that knocks it up to 150th of a second. However, if we've got like a 4 times stabilization effect, some lenses are only 2 times stabilization, so you need to factor that in. So we could, with a 4 times stabilization, now reduce that by 4 stops down to a 30th of a second. Similarly, with a 200mm, blah 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 blah, and you can work through that, goes down to about 150th of a second. Now, if we start looking back, 30th, 50, 200, 150th, we're almost back to the same 50, 50, 200, 200th of a second. So make of that what you will. The effectiveness of this rule is something you need to experiment and adjust as necessary yourself. So any relative movement between the scene and the image projected on the camera sensor will produce blurring, and stabilization is a method for reducing some of the blurring effects. So two of the main stabilization systems built in are where the stabilizer is built into the individual lenses, or where the camera sensor is moved to achieve the stabilization effect. So auto stabilization can help reduce some of the following effects. Hand holding your camera in a steady position, it's good for that. When smoothly panning with a subject, some lenses have got special panning settings. The Canon lenses, it's usually stabilization setting number 1. The effect tends to be most useful with telephoto lenses. Modern equipment has more effective stabilization than the older equipment. Auto stabilization is not effective or actually causes problems for long exposures. We don't want the stabilization system jittering, because long exposures are usually on a tripod or a solid mount, so we need to turn it off. When the camera is tripod mounted, when trying to follow erratic moving objects, because the stabilization system has got nothing to actually lock onto to decide what is movement and what isn't movement. When parts of the scene are moving relative to each other, it's not going to arrest that. And of course it consumes battery power, so if you're limited on battery power, maybe you need to consider taking the stabilization off and tripod mounting. So let's have a little look at an example. So this is a scene I took, and I took 2 images. It's a 300mm lens, f16, 60th of a second, effective VR, so it was handheld 4 times. So that's without vibration reduction, and that's with vibration reduction. I think you can see it's been quite effective, even just looking at it with this small screen here. Okay, panning, so this is where the camera is moved relative to the subject, so the background has been allowed to totally blur. Part of the image is lovely and crisp, other parts of the image that are moving themselves have become blurred. Okay, but panning is a technique that you need to practice at to get effective. So select the appropriate shutter speed and aperture, position yourself and practice the expected sweep of the movement. Try and imagine how it's going to happen, or do it on several things that have gone by. Autofocus, I normally set it to AI servo or similar, so that's where the camera anticipates where the subject's going to be when the shutter actually opens. Lock your focus on the approaching object and keep focus points on the object as it's moving towards you. Smoothly swing the camera around in sync with the object's movement. Operate the shutter as required and experiment with different shutter speeds to see what effects are the most effective. Some people manually pre-focus on a particular distance, maybe here, before they press the shutter. That can be quite effective. It's up to you to see what is most effective with you and your own equipment. So once again, let's hope that that's given you some idea of how we can reduce camera shake.